Hello, and once again welcome to my workshop. Today we're going to do a laser project. In fact, the next two videos are going to be laser, as I've got about 20 laser videos on my channel, and to get to them just go to my opening page, wrong mouse, and scroll down till you come to created playlists. Click on the underside there and the full listing will come up. There's about 20 that I've done so far, and over the last couple of months they've taken off, because I do understand there isn't very many technical videos explaining how a laser works and how to use them, and how to use the programs that relate to them as well. In my case, I use LaserCut 6.1. So in this video I'm going to show you first of all how to get a piece of material, and in this case this is fairly thin plyboard. So what I'm going to do is we're going to draw directly in LaserCut 6.1 just a test card. And when I say a test card, I mean we're going to draw a shape like so with a key, and then another square shape with a receiving key. So when they're cut out, one fits into the other very snugly, because a lot of multiple parts that are cut on a laser are put together with these key type joints. But it's not a simple process of, oh, just set the laser going and you draw something and off it goes. It is not that simple. So I'm going to take you behind the, I suppose, the science of it, not too deeply because I don't want to bore you, of how to make a cut, how to determine the power level to actually cut through this cleanly without burning, and without, you know, sort of without leaving the part high and dry in here because the laser hasn't cut through all the way cleanly all the way around, and there again are not burning and having fires or leaving black charred material. All this has to be taken into consideration, and what I teach then is directed towards either a home hobbyist or a small business, because I personally have a 100-watt laser, and I do urge you to go and see my first videos regarding that laser and when I received it and what I tell you about it, because it's too much information to go, you know, sort of repeating in every video. So I urge you to go back and have a look at my first videos regarding that, and it'll give you the tools to assist you to purchase your own, because out there it's a minefield. Okay, so I'm going to start you off on the process now of doing this test card, and you'll see what it's all about as we go into the video and start cutting. Okay, so we're going to start by opening up LaserCut 6.1. I recommend this program to anybody. It's a very easy program to use, and it does really everything you want to do with a laser. So there are other programs out there, but I prefer this one myself. RD Works is another good program. and I think later on in the year I might start using that one as well. There's not really much difference between them. I find this one more simpler, that's all. Okay, so our material is 3.5. Depends on where you measure it. 3.5. It varies between 3.5, 3.4, 3.6, so you know, it's plywood. So what we need to do is just make this test card. So very quickly, come over here to this top left hand corner, pick a tool and just draw a 2-inch square. We can make that exactly 2 inches just very easily by doing this, going and right clicking, size, and uncheck this, because otherwise that'll keep the aspect ratio the same, and if you alter one figure it'll alter the other one at the same time. So uncheck that, and we just want 50 millimeter, which is not quite 2 inches. To be exact, we'll make it exactly 2 inches. So it's actually 50.8 millimeters. That's exactly 2 inches. It's 25.4 millimeters to an inch, for those of you not quite sure. So we'll make it exactly 2 inches in millimeters. And we press OK. We're not really interested in having it exactly on one of the squares. It's okay as it is. This is just a test card. Now, I'm going to go into the science of lasers and how a laser operates, or how beam operates, but I'll try and keep it to a bare minimum. So the next thing we want is our peg. So we're going to draw that up here. So it's another box, and that one needs to be resized to, I think 20 millimeters fine there, and 3.5. 0.5, not 35, 3.5. Okay, so that's resized. We'll just move that. So to move something now, right, if I just went on here and tried to grab this and move it, it'd just draw another square. So you have to change the tool up here, and so let's roughly get it on there. That's pretty well exactly on there, actually. Yeah, that's pretty well bang in the center as well. Okay, so now we've got that the right size. So we're going to make a copy of this now. So just come over here, array copy. We want what, 2 in the Y, gap 10 millimeters. So that means it's going to gap it out a little bit so don't get confused with others. So okay, it's as easy as that. This one, same. I could have done the two together, but I'm just showing it here, the easy way of doing it. So 2 and 2. There you go. That's sort of fairly easy way of making a copy. So we're going to put this alongside each other, and I like to leave a little bit of about a 5mm gap. If you leave a 2mm gap, when the laser comes and cuts this one and then cuts the other one, it tends to distort the material, especially if you've got maybe 10 of these. The material distorts and it puts the laser out of focus because I have my material raised off the bed, as you'll see shortly. So now we're going to get this and we're going to put it in the center somewhere, because when this is cut out, when these two are cut out, we're going to fit this one into that one and see what size fit it is. And I can hear you saying now, oh, but you've just drawn that one exactly the same size as that one. How do you know it's going to fit? It's going to be too tight or too loose? Well, this is where the science comes in. So I'll just save this a second. I want to show you now something about the laser itself, and maybe some of you may know, some of you may not. Okay. This is the shape of the laser. The laser is not a square beam like this, right? It's not a square beam like that. So on the outer side of the laser, it is colder then, or less energy, and as you go into the center of the laser, it's hotter or it has more concentrated energy. So if you can imagine, if the laser is coming along cutting through material, it's not a square beam cutting through it. It's more of a pointed beam. And the faster that you travel through the material with the laser, the less the outer part of the beam is interacting with the material, because this part of the laser doesn't get a chance to do anything. So it's only like the tip here that actually penetrates through the material and actually does a cut. So this part of the laser, as it comes out of the end of the laser tube, in my laser's tube is 12mm. That's the distance across the actual outlet of the laser then, the outlet of the tube. And that is the actual diameter of the beam that gets bounced around in the mirrors. We're going to be traveling about 20mm a second with the laser beam cutting this ply out. So I know through experience that that rate of speed cutting the beam itself, the penetration of the beam, is about 0.9 of a millimeter. So when it comes to, I'll just drop this out now, so I think you all understand this. This incidentally is called a Gaussian shape, and that is the shape of the laser. So if we go back to our material now, so when this is cut out, there's going to be overall, cutting this side and cutting that side, a gap then of 0.09 of a millimeter. So it's going to be half this side and half that side, making 0.9 extra space. And that just so happens to be a nice clean fit for this to fit into. So the actual measurement of this is going to be 3.59. Okay, you understand? So I hope you understand that. So there's a small amount of science and understanding of what a laser beam is, even down to the shape of it, and the faster it moves through the material, the narrower the beam. So all these things need to be thought about when you're doing a job, or you have to have these in the back of your mind, or understand the principles of a laser or the operation of a laser. So we have now our two shapes that we require. Now the next thing to do is to cut these in the right sequence. So if we cut out the outside shapes first, that means we wouldn't be able to cut the inside shape of this one. So even if it was lettering, you need to cut the inside shapes out first. So that's what we're going to do, and we're going to put that on a separate layer. To do that, we're going to alter the layers that the main objects are in. We're just going to shift select, and we're going to put those on a blue layer. Simple as that. Just select the blue layer down here, and the blue layer comes up there. And whatever is in the listing up here, that is what the laser will do first. So it's going to cut the black layer first, which is what we want, this one. Now then, power settings. So I'm going to take a stab in the dark here. So this one first. So we double click, and then this dialog box comes up. Okay. Work speed. We're going to go 20 millimeter per second. Leave that one blank, it doesn't really matter much. Oh, this is way off. Okay, this is the strike of the arc. In other words, the initial startup of the laser, the power required to punch a hole straight through. So in this case, we're going to say 42%. Now this one here, this is how much, because the laser travels in a direction, and then it slows down, stops, and okay, then goes to a different direction. Sometimes you need a higher output of the laser just to cut the corner. So we're going to say 42 in there again. Now this is actually set up for multiple laser heads, so power 1 level is the only one we're interested in. So we're going to say 40. That's 40%. And because we're cutting, we're not etching, so it's 40 power level 1. Power level 2 is also going to be 40. When you're cutting, always make sure that power level 1 and power level 2, or minimum power level, are set the same. 40-40. Blowing mode on. Now, you need blowing. Now the blowing is the air that's coming out through the laser nozzle then, to blow the smoke and the material away. Okay, always have it on. Fly cutting. That's really all you need to to set up. If you had a full sheet inside your laser and you needed a particular area or measurement where you wanted the laser to come and start cutting, that's when you fill in these XY coordinates here from your home position. The home position is over in that corner, in my case with my laser, is over in that corner there. That's the 0, 0. And so you would set up maybe 600, 300 here, 600 and 300 to start the laser in a particular area. So that's what this selection is here for. So now all you need to do is press OK. The computer has calculated that now, and it has written the G code. Yes, G code, all the same. These are all CNC machines. So really it's just an identical process for this one. 20 millimeter, nothing, 42, 42, and 40, and 40, I'm setting these figures because I know they work. This particular material, all materials different. You should test a little piece on each sheet that you get because this power level might be too much. We'll see when it's cut. Might be too little as well. So now we'll load this into the laser and do our first cut to find out what these parameters are for this material and whether this key is going to fit into that slot successfully. Okay, first things first, placing the material into the laser. Now, what I use is a mild steel or black steel plate on top of the honeycomb. I really I'm not a great lover of the honeycomb because the material, if you use the honeycomb, the material collects on the inside of the honeycomb and it can make a mess on the underside of your material, your good material that you want to keep. So what I do is a more simpler and cleaner way, I think, is use a black steel because black steel doesn't readily reflect the laser. Do not use aluminium. Aluminium will reflect about 97% of the laser off it. Okay? So you can do yourself some damage with that. So just be aware. And what I also use is these little magnetic, if I can get one off, they're a bit tight. They're just little magnetic coat hangers actually, that I take the little metal piece out of, and I just use those just to raise the material off this. Because what happens is the airflow is taken down the back here, and the air comes in through the front of this grill, and also up through and across to remove the gases and smoke and material out, and then through a filtration system. So what you need is an air gap on the underside of the material and a good airflow to allow the waste material to be taken away. Now, that's a couple of things there. Another thing, when you put your material into the laser, it's all about focus. Now, my particular laser, I've got a 2-inch lens in there, and I know that the optimum focus for the laser from the end of the nozzle to the top of the material is 9.5 millimeters. Now, this has got automatic leveling. I'll show you how to use that now. But if you notice, this material, I don't know whether the camera can pick that up, there's a slight warp in it. So when you put it down, okay, there's one corner sticking up slightly. No matter which way you put it around, this corner always sticks up on this particular piece of material. So to get rid of that, and you need to get rid of that because otherwise the laser may be focused here, but over here it won't be. You get my meaning? There's about a 5 millimeter piece poking up there. So you need to be able to get this down flat. Okay? Flat and as even as you can. So we'll do that right now. The simple solution really is just to get a couple of pieces of wood under this side, this end, to force that end down. And really it's as simple as that. Okay, so this is square material, so I know it's squarely up against here. So I know that edge is going to be running square with it. So what I'm going to do now is I shall transfer that little bit of code into the laser and we'll set this up. Okay, so this is now on the little computer that operates the laser, so we'll just switch the laser on. Some of you might not think that this is important, but it is very important to have a filtration system, because when a laser is cutting or etching, it is turning whatever material that you are cutting, plastic or whatever, or wood, it's turning it to gas. It's also important to have a filtration system. I've also had a lot of you contact me saying that you're having trouble getting your computer to actually connect to your laser. And I'll show you what you need to do to promote a connection computer to laser after installation. You got it switched on. You must have the laser switched on, plugged into the USB. Come down to this right in here where it says connection failed, and double click it twice and it'll go green. That means that your computer and your laser are connected together and they're talking to each other. So now we will upload this program, test 1. Okay, and that has gone now to the laser. We're now going to set the Z height, or the height of the laser nozzle above the material, to the correct setting. Now I'm just using the arrow keys on the controller. Now on the back of my nozzle there is a proximity sensor, and this is just a mild steel plate that's covered with like a plasticky coating. So now I'll just set it to automatically set the height. And that's it. So that's set the Z height. So now we've got to set the X and Y. Now I like to leave about 5 millimeter to the edge of the material and about 5 millimeter in between parts that we're going to cut. So now I'm going to set that datum. So that's the datum origin, or the 00 for the laser head. So now we'll do a test to run around to see whether it fits in there. We know it will, but it's always good practice to do it anyway. So okay, so we're ready now to cut. So what I'm going to do is I'm going to zoom the camera in so you can see this cutting. I won't speed it up, it'll just be live. Didn't drop out, and you can see here that it didn't quite make it through all the way, did it? It didn't go through at all. So, and there's the reason why. Can you see that? We have a light material here and a dark material here. This is hardwood and this is light wood. So all I'm going to do, that goes all the way through that end. So what I'm going to do now is not change any settings, just turn the material round so it's the softer wood, and we're going to do exactly the same cut. Okay, same cut, same parameters, here we go. I'll just do a test first. Okay, that's fine. Let's cut it. There you go. Drop straight out. Clean cut through. In actual fact, the cut edges are slightly dark, so that tells me that we could probably reduce the power level a bit, and that fits in there absolutely perfectly. Okay. So that allowance, that bit of a gap, you can't actually feel any movement there at all. But it's just a nice fit, and you can tell there's a little bit of carbon on there. So yeah, the power is probably a little bit too much. So what I'm going to do is right here live, I'll alter the setting. And instead of reducing the power, we're going to speed the process up. In other words, instead of 20 millimeters a second, we're going to go to 22 and see what difference that makes. Okay, so I've set the new datum. We'll just do a test. Okay, it's going to fit in there and immediately cut. So this is 22 millimeters a second. Still drops out. You can see all the smoke is coming out from the underside, so that means it's cutting through. It's a good indication. It'll probably poke out. Yep. Okay. still fits in nice. Slightly lighter, it's slightly better. So you put those together, you can see that these are actually darker than these. So now I'm going to set it at 24, maybe a little bit too much. I'll set it 23 millimeters a second. Okay, so this is 23. Let's do a test. Okay, straight into cutting. Yeah, that dropped out too. Yeah, that's pretty well about the limit, I think. And I can actually feel that getting a nicer fit. Look at that. Quite a nice fit. And there's the the three lots that we've done. Just 20, 22 and 23. So you'll notice a slightly darker shade this side than this side. So the 23 millimeters per second is about right. I'll just give you a better shot of that. Okay, I hope the camera can pick up the extra shade in here. So the higher, the slower speed is this end, and the higher speed is this end. So it's 23 this end and 20 this end. So you can see you don't necessarily have to reduce the power of the laser to reduce the burn, or the burn-in, the amount of burn-in then. You can speed the laser up so it's not in contact with the material so long. And also the knock-on effect of that is the actual cutting part of the laser is a narrower beam. If you move in faster, it becomes a narrower beam. And if you have a slot like this that a peg fits into, it becomes a better fit. So there's parameters that you can change to alter the outcome. So I hope that's been a help to you, and I want to keep this video fairly short, and I'm going to start a video in the next segment of this. So this segment will actually be 2 videos, and I hope to have that up for you Saturday night US time, because this is Friday in Australia time. So it takes quite some considerable time to sort of film this. Just this segment has taken about 2 hours to film, and then I'll probably spend another 3 to 4 hours cutting and editing and what have you, and uploading onto YouTube. And so thank you for joining me, and I hope you've enjoyed this video, and hope it's been informative for you. And I'll see you again hopefully on Saturday night. So bye for now.